Hi everyone, let's talk about the quadratic formula. What I'm going to do is show you the usual way of proving the quadratic formula, and then afterwards I want to show you a better way of proving it that avoids some of the casework. But both methods will boil down to a method called completing the square, where in essence we get rid of the linear term by absorbing it into the quadratic term, and that allows us to isolate the variable. And I'll show you exactly what that means in a moment. So let's do the usual method. The usual method says that we start with a quadratic equation, ax squared plus bx plus c equals to 0. And a, b, c, they can be real numbers, but we'll say that they're complex numbers so that it's a bit more general. And a is not 0 so that it's truly a quadratic and not a linear or constant. So what we do in the usual case is that we start with ax squared plus bx plus c equals to 0. And since a is non-zero, we can divide out by it. So we get x squared plus b over ax plus c over a equals to 0. Then we rewrite the second term so that there's a coefficient of 2. We get 2 times b over 2a x plus c over a equals to 0. And now we're going to add in a constant term over here in the middle so that we can factor that constant term plus what's here. So that's going to be the square of b over 2a. So we get x squared plus 2 times b over 2a plus the square of b over 2a. And we're going to take the c over a over to this side. So we get b over 2a squared minus c over a. Now let's factor what we have over here. So we get x plus b over 2a squared is equal to b squared minus 4ac. We're already starting to see something that looks like the discriminant over 4a squared. Now we're going to take the plus minus square root of both sides. So we get x plus b over 2a is equal to the plus minus square root of b squared minus 4ac over 4a squared. And that we can use the distributive property of the square root to say that it's equal to plus minus square root of b squared minus 4ac over the absolute value of 2a, since if you take a square and then do a square root, you get the absolute value. And then we just isolate x to get negative b, x is equal to negative b over 2a plus minus this fraction where we have the square root of b squared minus 4ac over the absolute value of 2a. And it's really the absolute value that's the annoying part. We have this absolute value here. And what's going to happen is that we have to do casework. Casework on a is greater than 0 or a is less than 0. Now thankfully the casework cancels out to the point that you can just get rid of the absolute values, and it cancels out because of this plus minus sign. But formally speaking, you still have to do some casework to get rid of the absolute value. And I'm going to show you a method now where you don't have to worry about any casework at all. So the new method, which is not an original method, it's known, but the less orthodox method is to complete the square in the following different way. What we do is we multiply instead of divide at the first step. So what we get is that ax squared plus bx plus c is equal to 0. That's what we start with. And what we'll do is multiply both sides by 4a. So we get 4a squared x squared plus 4ab x plus 4ac is equal to 0. And we're going to write the first term as 2ax squared and the second term as 2 times 2ax times b plus 4ac is equal to 0. And now it should be clear that what we're going to do is that we're going to insert a b square in here. So what we get is 2ax squared plus 2 times 2ax times b plus b squared, and we'll take the 4ac over to this side. So what we get is b squared minus 4ac. Now let's factor what we have over here on the left side. We get 2ax plus b squared is equal to b squared minus 4ac. And if we start isolating x, we get 2ax plus b is equal to plus minus square root of b squared minus 4ac, thankfully without any absolute values. And if we isolate x, we get negative b plus minus square root of b squared minus 4ac over 2a. And that is our quadratic formula. So you see, in this case, we were able to avoid any kind of casework, and that is the advantage of this less usual method. And if you want, you can state that all the steps are reversible. So that means that these are the only two solutions, and they might also be equal. You have to do some analysis of that to determine whether they're equal or not, and that depends on the discriminant. Okay, thank you for watching, and I'll see you next time.